Hi guys, in this video I'm going to do a quick recap of yesterday's work and give you some examples of more complicated type of equations, and then from there I'll give you an activity. Okay, so these are kind of similar questions to what I gave you yesterday. The first one, the x is in the exponent, and the second one, x has an exponent of 3. Okay, so remember, if x is in the exponent, I first need to change my bases to be the same. Okay, so there the base is 7, there the base is 49. If I do change the bases to be the same, I can drop the bases and just work with the exponents, which is where x is, so that's where I want to get to. Okay, so I need to try and write 49 as the same as 7 to the power of something. Okay, so 49 can be written as 7 to the power of 2. Once I've done that, I see that this base here is over 1, right? So this one here has a numerator, this one here has a denominator. So I'm going to move this base over the fraction line so that it can also become a numerator, and if I move any base over the fraction line, I know the exponent is becoming negative. So I'm going to have 7 to the power of negative 2. Now they're both numerators, both of their bases are 7, so I can drop their bases. So I'm going to have x plus 2 is equal to negative 2. And from there I can just solve for x. So I'm going to bring the 2 over and subtract it. Minus 2 is equal to negative 4. Alright, let's try number 2. Okay, number 2, I'm going to start by just trying to get x isolated by itself. So I'm going to move the negative 2 over the equal sign and add it. That will give me 81. From there, I can divide through by 3, and that will give me 27. And from there, I need to get x alone still. So how do I get rid of a cube? I cube root. And once I've cube rooted, I'm going to find that x is equal to 3. All right, let me show you something that's a lot more complicated that would be considered a level 3 question. Okay, so here, please will you make sure that you're writing this down. I've got x to the power of 3 over 4 is equal to 8. Okay, like it says here, don't worry about the 3 over 4 for now. Let's just do what we usually do and change the 8 to a prime base, so a prime number to the power of something. So 2 to the power of something. Okay, 8 can be written as 2 to the power of 3. Okay, now this part, at this part, you don't really know what to do because you can't drop the bases because the one base is x and the other base is 2. So you need to do something to the exponents, okay? And this is what you do. You raise both sides to the power of the inverse fraction, okay? So if I look at this fraction here, it's 3 over 4. The inverse will be 4 over 3. So what I'm going to do is I'm going to raise this side to the power of 4 over 3, and I'm going to raise the right-hand side to the power of 4 over 3, so like this. Okay, so now what I've done is, so if we can read it, raise the base to the power of the inverse fraction, and then because I'm raising a power to a power, I would multiply the exponents. Okay, so if I say 4 times 3, that gives me 12. 4 times 3 gives me 12, so I've got 12 over 12 here, which is just 1. So I've got x to the power of 1. This one here, if I say 3 times 4 over 3, I'm just going to get 4. So I'm going to have 2 to the power of 4. And now I can solve that. So x is equal to 2 to the power of 4. 2 to the power of 4 is equal to 16. Okay, so if you wanted to check yourself now, you could say, okay, well, let me substitute there. Is 16 to the power of 3 over 4 equal to 8? Yes, it is. Let's do another example of one of these. All right, so in this example, I've kind of got something similar, except now I've got a 2 being multiplied with the x. So I'm going to divide through by that 2 first. So if I divide this side by 2, the 2's will cancel. If I divide 32 by 2, I'm going to get 16. Okay, so at this point, I need to basically get my 16 as a prime base. So can 16 be written as 3 to the power of something? No, it can't. Can it be written as 2 to the power of something? Yes. Okay, 16 is the same as 2 to the power of 4. All right, now, again, my bases are different, so I can't drop them, so I need to do something to my exponents. So there's my fraction, 2 over 3. Well, negative 2 over 3. So my inverse will be negative 3 over 2. So I'm going to raise both of these to the power of -3/2, and then I'm going to have to multiply my exponents. Okay, so if I multiply -2/3 by -3/2, I'm just going to get 1, positive 1, right? So I'm going to have x to the power of 1. And here, if I multiply 4 times -3/2, you're going to see you're going to get -6. Alright, from there, I never leave my exponents as negative. So because this is over 1, I'm going to move this base over my fraction line, and the exponent is going to change from negative to positive. Then I can work that out. So x is equal to 1/2 to the power of 6, which is 1/64. Alright, so these would be considered quite complicated examples. This is like a level 4 question. Alright. Alright, so for homework, this is the exercise that I'd like you to do. So I want you to do the whole of number 1, I want you to do number 2, and number 5. Okay, good luck. If you're not sure, then you can have a look at the memo, which I'll post on Google Classroom.